Okie dokie, I have tested things out and hopefully this video is actually recording sound now. So let's talk about watersheds. What are watersheds? Well, a watershed is a chunk of land that whenever precipitation falls on it, water gets on it, it's going to drain to a specific stream, and that's going to lead out to a common outlet of some sort. So if we look at this diagram here, we see an area of land that's surrounded by this kind of dark gray border that's labeled as the basin area. And down here, we have an area where the stream exits. That is the outflow location or the outlet location. And all of the land on this little diagram right here, the water that falls on it as precipitation or if you're watering your yard, is all going to drain to this one area. This includes not only the surface water in that area, lakes, streams, etc., it also includes the groundwater, which we're going to talk about more in Unit 5. And all the land that drains to a specific outflow point is the watershed for that outflow location. What I mean by this is going to become a little clearer when we talk about some of the various properties of watersheds. So, with that in mind, let's look at a map of some of the watersheds in the US. They're defined a little differently than some of the watersheds I've seen. So, for example, you don't see the Trinity River watershed, which may just not be included on here, or it may have been included in something else because the Trinity River should be in about this area because it drains into Galveston Bay. But you can see some of the major river systems, like for example, here is the Mississippi River. And it looks like they've taken the Mississippi River Basin and they have broken it into subdivisions. So let's take a more detailed look at that. So this diagram shows you the entirety of the river, the Mississippi River's drainage basin. Every river that flows into the Mississippi is depicted on here. And the land that's drained by that. Now, what you see here is this is a very large area watershed, and this is a watershed that we're looking at if we're examining the outflow point of the delta of the Mississippi River, which is where the entire river empties into the Gulf of Mexico. However, if we zoom in on a particular area, so notice that this is a color-coded map. Let's look at the lower Missouri, which is this guy right here. This is also considered a watershed, but it's a watershed for the lower Missouri River, and it is defined as all the land that drains to this outflow point, which is the point at which the lower Missouri River ends up draining into the Mississippi. So we can look at a watershed that's that green area, which is the lower Missouri watershed, or we can look at the watershed for the entire Mississippi River, which is going to be this entire diagram, all the colored bits, with the exception of the Great Lakes up here. Those are a completely different water system. There may be some drainage into the Great Lakes from the surrounding land, but the vast majority of that's going to go into the Mississippi River. So, if we're looking at and defining our outflow location as the Mississippi River Delta, the area that drains to that region is 3.2 million kilometers. But if we look at that second outflow region where the Missouri River joins with the Mississippi River, the watershed area for that region is just 4,100 square kilometers. So you can define the watershed you want to look at. I've seen some things in my reading that talk about looking at a watershed the size of a footprint, just because anything that falls water-wise in that tiny area will drain to a specific point. So the area as well as the length of a watershed are really going to depend on what you're defining as a watershed. So the length of a watershed, and this is the diagram you have on your notes, is dependent on the length of the principal stream that you're tracing. So the principal stream is going to be the major stream, probably the one with the thickest flow, the one all the other tributaries feed into, and this right here is the principal stream in this diagram. Put together, the area and the length of a basin of a watershed are going to have an impact on certain things. So, two of the major things you'll see in a watershed is runoff. surface water running along until it drains into the nearest body of water, as well as erosion, because as water runs off, it tends to carry soil with it. And another thing that we'll look at is we'll look at percolation or infiltration, which is water moving through the ground and to joining the groundwater supply. So when you have a larger watershed, then it's going to take a longer time, and there's going to be a longer distance for water to travel from the very furthest area. So if this area right here where the star is the most remote region from your outflow, it's going to take a long time for the water that's running off to travel down to this outflow point. On the other hand, if you look at the smaller area, then you're going to see that it's going to take less time for water to run down into the outflow area, as well as it's going to be traveling a shorter distance. If it's traveling a longer distance, it's going to pick up possibly more water along the way, and it's probably going to pick up some soil along the way as well. Another thing is, if you're doing like city planning or management, you have to think about the impact of storms. So if you have a storm system, say that's this big as I've drawn on the diagram, notice it's only impacting part of the watershed at a time. That's what happens when you have a larger area watershed. On the other hand, if you're looking at a smaller area watershed, there's a greater chance that a storm of the same size could actually impact the entire basin. And this can be very important when you're looking at, for example, flooding and what happens downstream. So you may see periodically on the news if there's flooding in regions of the kind of central to eastern part of the United States that drains into the Mississippi. They'll talk about the flood water. So if this was a big thunderstorm and a lot of water was flowing along, you'd have a lot of water coming here, and then that water would basically thicken this stream until either it gets far enough that it's kind of able to melt into the kind of background flow, or until it reaches its outflow into a body of water. And so, you might have people having to kind of evacuate from those areas if they're in the floodplain. On the other hand, in the other area, the smaller area, you might have a lot more of that impact down here where the stream is almost at the outflow. But it's gonna change how water is flowing to the nearest body of water, which changes how flooding happens, which is important for city planning. Also, the slope of a watershed is going to have an impact as well. So here we see kind of the typical diagram of a watershed, and you'll notice that there's these higher elevations. These higher elevations are usually going to be the boundary between two watersheds. And they're also going to be important because they're going to have the highest slope, which means they're probably going to have higher rates of runoff and higher rates of erosion because water is going to be traveling faster, carrying more sediment with it. And then once you get into like the floodplain, which is usually a flatter area, the river slows down. It's in all likelihood going to have less erosion. In fact, it's probably going to deposit some sediment. And so all of these things can depend on the slope. You can also have impacts of the soil composition. So remember, we've talked about sand, clay, silt, and gravel. Sand lets water pass through. Clay tends to hold on to water and become waterlogged. Well, the amount of sand versus clay that you have in a soil can affect how it retains water. If it retains water, that can impact runoff. So if you have something that is all clay, well, that clay, once it gets rained on, is going to have a lot of water build up. So these are like puddles. And that water doesn't really sink down into the ground because the clay doesn't let it pass through. So you might have more water build up and you might have some flooding start. Whereas if you had a different area of land that was sand, you might have a lot of water coming down, but instead of pooling on the surface, it just kind of sinks into the ground and joins the groundwater. So, because of this, the soil composition and how it impacts water retention is going to change runoff. It's also going to change erosion because if there's more runoff, there's usually more erosion. More water flowing carries more stuff with it. And this also affects the infiltration of water to go down into become part of groundwater. So this is the example where I talked about where if you had a high clay content, then you might be retaining water, and then you will have less water that's able to sink down into the groundwater. So you might have high runoff and the low water infiltration. Another thing that impacts watersheds is the vegetation that you have in an area. Hopefully, you remember from when we talked about soil that the roots of plants help hold soil in place. In fact, if you look at this diagram, you see this kind of intricate network of roots that's going to help keep dirt and soil in its place. So, like I said, roots anchor the soil. They also decrease erosion. And when you have older plants or plants with more kind of intricately divided up root systems, then you will have them holding the soil in place with greater ease. And so they will help, especially to stabilize soil. Whereas if you have maybe some short grasses with short root systems, and cats meowing in the background, that soil might be a little easier to erode. Um, and then another impact that vegetation tends to have is when water is flowing through vegetation, it tends to get slowed down, which can decrease runoff and erosion and also allow for more infiltration of water into groundwater, which will become really important when we talk about our sources of like drinking water, for example, in Unit 5. Here, this is just a diagram again showing you some of the major watersheds. For example, here's the Trinity. I emphasize the Trinity because it is our local water source and our local watershed. Notice these areas where you see this kind of junction between two watersheds. That's usually going to be a high ground. So it's going to be a higher elevation and water will flow on one side of that into one watershed and on the other side into the neighboring watershed. And that is about it. We'll be moving on to some more weather and climate stuff with the next lesson.